All right, this is the first one. So I gave you the range at -2 to 2. Those are the points you want to plug in for t. Okay, plug in the -2. For the x, you get 4. For the y, you get -4. Plug in -1, you get 1 and -3. 0, 0, -2. 1, 1 and -1. And then 2, 4, and 0. And then you want to apply your curve. Make sure that your curve has those arrows, okay? So it actually can stop here. You don't need to go beyond here because it said to stop there. Like that says to stop. If it didn't give you a range and you just plug in some points, you can have that continue on past there. But make sure that if it says to stop, given t is up to and including 2, that last one will be your end point, and then your arrows have to be there. Again, there's not a specific amount of arrows that have to be there. But they do have to start with the first one, the first or the lowest t that you plug in and point to the largest t. Okay, most people did pretty. All right, second one. This time you have to solve for one of the variables for t. I just picked the second one. They were both probably equally the same amount of steps. So I picked the y, solved it for t, and got x plus 2 over 3. And then you want to take that and plug it into the other equation, the one you didn't solve for, and you would have gotten that y equals 2/3 x plus 7/3. This is a line, which it can happen. And then you want to plot your line. This time we don't know where it starts and stops, so the endpoints can be those arrows. This is if you had solved for the x for t. If you'd solved the x for t, you got a t equals x plus 2 over 3. Take that, plug it into the y, and you still get the same answer. So it doesn't matter which one you do. Just be really careful. And you don't know the direction of these arrows, so I would have left the arrows off. Just be really careful. You don't know what's the orientation. Unless you plug in like 4t, -1, and 1 and see where it's going, you're not necessarily going to know the orientation of your graph, so you don't need those arrows. Third one said to find the set of parametric equations to represent the graph of y equals 4 minus 7x, and you got t equals 2 minus x. Remember, in this scenario, one of them is going to have the t. In this case, the x did. You want to solve that first for whatever variable's with it, which is the x. And you get x equals -t plus 2, or 2 minus t. Order wouldn't matter there. And then you take that and plug it into the other equation, the one that didn't have the t, because you need it to have a t. And you get y equals 7t minus 10, or -10 plus 7t. The end result should be two equations, one x equals and one y equals, where they both have a t involved. questions on any of them? You guys are pretty good on the format. We're good? Okay, so 9, 5, and 9, 6 are about polar. 9, 5 is about polar coordinates, which are like coordinate points on a polar grid. And then when we come back from break, we're going to learn about graphs of polar equations. So we start with foundation, which is what the heck is polar, right? So a polar coordinate system is formed by what looks like your coordinate grid, x-axis, and a radius, okay? And then you'll use a special kind of coordinate plane to graph these on. So to form the polar coordinate system in the plane, it starts at a fixed point, which is O, or the pole, or what we're used to, the origin, 0, 0. And then you'll construct from O an initial ray called the polar axis. So the polar axis, which is, I would say, formally known as the x-axis, because now we're going to call it a polar axis, starts to the right side. So where like 0, 0 would be. And then it's going to give you an angle and a radius. So you're going to move in the direction of your angle just like we normally would with our unit circle. And we're going to go out the distance that is the radius. So this is the idea behind a polar coordinate plane. Okay, so it looks almost like our unit circle except that it has rings on it. Technically, the unit circle would be up to this point because the radius would be 1. So the difference between the unit circle and the polar coordinate or the polar grid is that the polar extends an infinite amount of radii out, okay? So each bolded ring is 1 ring or 1 unit away from center. And then on this one that's drawn, that you have like in front of you, they only gave a couple of angles moving around your unit circle. You would need to know all the major angles. So you would also add in here, obviously, pi over 6, pi over 3, and all the pi over 6s and pi over 3s around. You don't have to know, like you don't have to have it completely filled in, but you do have to know where they are. So you might want to review your unit circle yet again, okay, because we're going to use those. So a polar coordinate is going to be given in the format of r comma theta, r being the directed distance from 0 to p, or the radius length, and theta being the directed angle. That would be one of your unit circle angles or somewhere on my circle that's counterclockwise if it's positive from the polar axis, just like every other unit circle angle. If it was negative, we would move clockwise. So the only difference between what we've done with the unit circle before is we stopped at 1, and now we're going to go beyond that. The polar coordinates is just a point, though. Notice it says a point, okay? So if I were to move around my, like, out of certain rings or whatever and then stop, the actual point is your answer, not the ray that gets you there. So this is a polar coordinate, which is a single point. And again, it's always in this format, radius, comma, theta. So it's a length, comma, an angle. All right, so this one says to plot the point, okay? And it gives you r and theta. I'm going to pull back in that polar grid. So the first one says 2 theta, or 2 pi over 3. So the first thing I'm going to do is actually locate pi over 3. Pi over 3 would be along this ray here. And then my radius is 2. So I'm going out 2 rings, 1, 2, and I plot my point. That would be 2 pi over 3. The second one says 3 negative pi over 6. So this time I'm going negative, which means I'm working my way clockwise. But negative pi over 6 would be the first major angle I would hit, which is here. Negative pi over 6 would be there. And the radius again is 3. So this time I'm going 1, 2, 3 rings out. That would be 3 and negative pi over 6. Questions so far? So 3, 11 pi over 6. 11 pi over 6 is the last major last major angle before you hit 2 pi. And my radius is 3, so I'm going out to the third ring, and I'm plotting my point. Now, if you compare this to what we just did, the coordinate point of 3, negative pi over 6 was exactly the same point. So we're going to learn we'll learn now that there's more than one way to name these angles where they would be, or name these points where they would be the same. And then in a moment, we'll talk about how you can figure those out. All right, so what happens when my radius is the one that's negative? Okay, this is where it's unique. I would still move to the angle. So if it's 11 pi over 6, I would still be identifying my angle, which is the same spot as that first one. But instead of moving along that ray, I'm moving in the opposite direction. So I would identify the opposite ray, which is actually here. That would be 5 pi over 6. And instead of moving 1, 2, 3 in this direction, I move the other direction, 1, 2, 3. That would be negative 3, 11 pi over 6. So if the radius is negative, you're going in the opposite, along the opposite ray from the one that you originally locate. Questions so far? Okay, so how do I find additional points? Because we just said more than one, a point can have more than one name. If it asks you to find an additional point, then you have two options. You can either take r theta, which is your initial point, leave r as it is, and then add and subtract multiples of 2 pi to theta. So I can add 2 pi or subtract 2 pi from theta, and it will give me the same point. I could add 4 pi, 6 pi, 10 pi, because they would be multiples of that 2 pi. The other option is from r theta, change the sign on r, but then add and subtract, and this really just means multiples of pi. So I can either add and subtract pi, 3 pi, 4 pi, that kind of thing, or the other way around. So I can subtract pi, I can subtract 3 pi, I can subtract 4 pi. So you'd be going, instead of just every integer, if it was n, it's every other n. That's what that little notation, that 2n plus 1, really indicates. Okay? And then the second part says, moreover, the pole is represented by 0 theta, where theta is any angle. So if I said 0 pi, or I said 0 3 pi over 4, or I said 0 negative 11 pi over 6, no matter where that angle is, if I don't leave the pole, right, because if my radius is 0, I will always be at the pole at the end, which is that 0, 0 part. So if this is 0, I never leave the pole. All right, so it says plot the point 3, negative 3 pi over 4, and then find 3 additional polar representations of this point using negative 2 pi is less than theta, which is less than 2 pi. So I'm going to add back in my polar graph. I'm going to plot 3, negative 3 pi over 4. So negative 3 pi over 4 is bigger than negative a half, but less than a negative whole, which means it is actually here, negative 3 pi over 4. And I'm going 1, 2, 3. Now to this, I want to find 3 additional points that fall within this range, negative 2 pi and positive 2 pi. So it can't be less than negative 2 pi, can't be bigger than positive 2 pi. So the first thing I said I could do is leave the r alone, so it would stay as 3, but then take the angle, negative 3 pi over 4, add 2 pi to it, or subtract 2 pi from it. So 2 pi is the same thing as 8 pi over 4. Negative 3 pi over 4 plus 8 pi over 4 is 5 pi over 4. Does that lie in between negative 2 pi and positive 2 pi? Yep, so that's one option. Then this other one I'm saying I'm going to keep r the same, but I'm going to subtract 2 pi, or 8 pi over 4. Is negative 11 pi over 4 in between negative 2 pi and positive 2 pi? No, right? It's too small, so I can't use that one. And if I continue to add or subtract 2 pi, it's still going to be too big or too small, which means I have to use my other method. The other method is change the sign on the r, but then add and subtract pi. So if I take negative 3 pi over 4 and I add pi, which would be 4 pi over 4, I get pi over 4, which falls between negative 2 pi and positive 2 pi. And then if I take negative 3 pi over 4 and subtract pi, I get negative 7 pi over 4, which is also in between negative 2 pi and positive 2 pi. So here are my 3 additional polar representations of that same point. Let's check them. The first one is 5 pi over 4, 3. Well, 5 pi over 4 is my original angle here. 3 would be that same point. That one works. The next one is negative 3 pi over 4. So pi over 4 is here, but I'm moving in the opposite direction. 1, 2, 3. That works. That's the same point. And then the third one is negative 7 pi over 4. If I'm going negative, I'm going around this way. 7 pi over 4 is actually the same angle, that pi over 4. And you're moving 1, 2, 3 units away again, same point. So these are easy to check. Plot them at the end. Make sure they would overlap with your initial point. Questions on that one? All right, coordinate conversion. So we can take what we now know is polar and convert it to rectangular, or our normal xy, or vice versa, take xy and convert it into polar. To establish the relationship between the polar and the rectangular coordinates, we're going to let the polar axis coincide with a positive x-axis and the pole with the origin. So we're going to take our normal xy axis and we're going to overlap our polar axis on top of it. This is still the x-axis or the polar axis. This obviously would still be 0, 0. The pole is still 0, 0. And then the rings are going to be as we move out from our center. The way we convert is here. So because xy lies on a circle of radius r, it follows that r squared would equal x squared plus y squared. Moreover, for r being greater than 0, the definitions of the trigonometric functions imply that tangent of theta is y over x, cosine of theta is x over r, and sine of theta is y over r. So think about why this happens. If I have a point, let's say this is 2 pi over 4. Then I'm saying my radius is 2. I'm saying my theta is pi over 4. And I can form from this a right triangle. So the x would be here. The y would be here. The radius, which is the same thing as the hypotenuse, would be there. So I can set up using SOHCAHTOA all 3 tangent, sine, and cosines, right? The sine of pi over 4 would be opposite over a hypotenuse, which would be y over r. The cosine of pi over 4 would be adjacent over hypotenuse, which would be x over r. And the tangent of theta, which is pi over 4 in this case, would be y over x. So all of that is where these came from. And then because it's a right triangle, the Pythagorean theorem would still work. X squared plus y squared would equal r squared, which is the third or the fourth missing piece. So to get from polar to rectangular, we need an x and a y, right? We're going from r theta to xy. X is r times the cosine of theta, which is what happens when you take and solve that equation for x. Y is r times the sine of theta, which happens when you solve this equation for y. And then to convert from rectangular to polar, you got to figure out what theta is. Tangent of theta is y over x, which is this equation. And r squared equals x squared plus y squared, which is this equation. So So everything is based on the fact that that polar coordinate would be the end point of the hypotenuse of a right triangle. These 4 formulas you have to memorize. All right, when you are writing the answers for these, you have to be sure to label the format it's supposed to be. So if you are showing your answer in rectangular form, you are literally going to give it to me as x, y equals, and then what it equals. For example, it would say x, y equals 2, 3, something like that. You literally have to give the x, y because it tells me if it's rectangular or if it's polar. The second one says when showing your answer in polar form, you write the answers r theta equals the number and the angle. So this would be like r theta equals 2 and pi over 6. Again, you'll give me the r theta first and then the radius and the theta. Most of the time you could tell the difference, but sometimes, obviously, if it's in radians, you can't tell the difference because it doesn't always have to have pi. And it's not like we're using degrees here. We have a degree symbol, so you got to be really careful. All right, so these say convert the point 2 pi to rectangular, and the second one, root 3 pi over 6 to rectangular. So in both, we're going polar to rectangular. And for those, you would get x equals r cosine theta, y equals r sine theta. So for the first one, x equals r, which is 2 times the cosine of pi, y equals 2 sine of pi. So hopefully you remember pi would be over here on the left-hand side. What would be the coordinate points for pi? On your unit circle. What is it? Good. -1, 0. So 2 cosine's the x, right? 2 times -1, which is -2. Sine is the y. 2 times 0, which is 0. So my answer would be written as x comma y equals -2, 0. Sometimes they are super easy to check, like in this case. If I just plotted 2 pi, I would know I'm going 2 pi, but 2 rings out. So this would have been -1, this would have been -2, and I actually could have gotten it just from graphing it. Obviously, they're not always like that. Okay, second one, B, says convert the point. Root 3 pi over 6 to rectangular. So x equals root 3 times the cosine of pi over 6. Y equals root 3 times the sine of pi over 6. Again, hopefully you remember pi over 6 on your unit circle is root 3 over 2 and 1/2. So I get root 3 times root 3 over 2. Root 3 times root 3 is 3 over 2. And root 3 times 1/2, which is root 3 over 2. So x, y equals 3/2 and root 3 over 2. That one you wouldn't have been able to get directly from your graph. You can test it out to see if it's close, but you're not going to be able to get an exact point from root 3 over 2. Questions on those? So that's polar to rectangular. Now we're going the other way. Rectangular to polar. And for these, you need tangent of theta equals y over x, and r squared equals x squared plus y squared. So the tangent of theta for the first one would equal 2 over 2, and the tangent of theta equals 1. So here's where it gets a little tricky because there are 2 spots in my unit circle in which tangent is 1, right? Tangent is 1 where they're both positive at pi over 4, but it's also 1 where they're both negative at 5 pi over 4. How do I know which one to pick? Where's that original point lie? Good. 2, 2 would be my first quadrant, so I'd know I'd pick the pi over 4. And then r squared would equal 2 squared plus 2 squared, 4 plus 4, which is 8. And r would equal the square root of 8, which I would simplify to be 2 root 2. So my answer, which will be written as r theta, is the radius 2 root 2, comma, the theta, pi over 4. Questions on that one? Okay, B, same thing. Convert the point -1, 0 to polar coordinates. So tangent of theta this time is equal to 0 over -1, which is 0. And there's two options for tangent being theta. For tangent being 0, it's either at 0 or it's at pi. Which one are we going to pick? Pi, because -1, 0 would be there, right? So theta is pi. And then r squared equals -1 squared plus 0 squared, or 1 plus 0, which is 1. So r equals the square root of 1, which is 1. And r theta would be 1 comma pi. That's also an easy one to check. Questions on that one? All right, so the last thing in this section is going to be using your calculator to find these measurements, because what happens if they're not unit circle based? Okay, which is what would happen if you'd need your calculator. So in order to do this, yesterday we talked about parametric mode. Today you're going to have to put it in polar mode. And because all of these are in radians, it also has to be in radians. So the settings on your calculator have to be for this kind of question in radians and polar. Because if not, you will totally get answers. You'll have no idea they're wrong. So be really careful. So if we're converting, so the first one says convert the point 2.5 and 1.582 rectangular. That means that this is already in polar, which means that this is r and this is theta. So to get the rectangular, we have to do x equals cosine, well, r times cosine of theta, and y equals r times sine of theta. So I'm going to make sure my calculator's in polar and radians, and then I'm going to say 2.5 times the cosine of 1.58, and 2.5 times the sine of 1.58. 2.5 times the cosine of 1.58 is negative 0.023. I'm just going to keep all those decimals. And the y is 2.4998, or 2.5. So my answer would be written as x comma y equals negative 0.023 and 2.5. Questions on that one? And then B says convert the point 0.69 to polar, which is telling you that this is already xy. My answer needs to be polar. So the tangent of theta is 9 over 6. And I'm going to let the calculator do the work there. I'm going to do tangent -1 of 9 divided by 6. And I get theta is 0.9827, so 983. And then I would get r squared equals 6 squared plus 9 squared, or 36 plus 81, which is 117. And r equals the square root of 117. And then I'm going to write my answer as r comma theta equals root 117, 0.983. questions on that? So on your test, you're going to get a portion of it, which is calculator based. You'll want to make sure you're careful because, again, you won't know you're getting wrong answers when you hit buttons like cosine of 1.58. If it's in degrees, it's totally going to give you the wrong answer. So you got to be really careful.